of things that you guys have done. One of the first things that you guys did was that you guys dealt with this thing called slope. And we've talked about this already. Bless you. Bless you. Bless you. So we actually dealt with this one early. I get it. You're allergic to it. Whatever. We dealt with slopes already this year. And we dealt with them in terms of ordered pairs, if you guys recall. We can find the slope, ladies and gentlemen, we can find the slope of any line or slope between 2 points if we know their coordinates. And what we did was we had a first set of coordinates and a second set of coordinates. And all we did was just label them. Slope in and of itself, do you guys remember what it was in terms of a ratio? Slope was what over what? Rise over run, okay? Slope, if you remember, slope, we call it rise over run. What letter do we use for slope again? Now, when we talk about rise in your coordinate plane goes what direction? Up and down, right? What values in your XY coordinate grid go up and down? Y values. Y values go up and down, X values go left and right. So what we say is change in Y over the change in X. I know we talked about the triangle represents change, Greek letter delta. Usually, I heard about that last year. This goes back to staring at the poster.
What does it mean?
Delta?
Yeah.
In geometry and math, it talks about change. So you have what's called the change in Y over the change in X. And how we figure out change is we find distance between values. And what we do is this. If we have a set of ordered pairs, we would use the change in Y over the change in X. I would go broke if I had to buy Kleenex for you guys. What if someone can't afford Kleenex? Why is that? What is that fair for? You know what I mean?
You're not learning.
It's if you're not learning anything if you're bringing in Kleenex. You're not learning anything if you're dressing up for class.
But here's what I would do if I know that I'm bringing this.
I'd bring something home.
I'm saying I give a box in my wallet.
Yeah, or I'd stop at the restaurant because you got a big bottle. Yeah, that's what I do too. Yeah. And that's just me. I've always been like that. I know that other teachers do that because I don't think it's fair to have kids say, hey, if you dress up and wear a tie for this, you get extra credit. What if the kid doesn't have a tie?
Or what if a kid can't buy food?
Right.
Yes, it's crazy. Ooh, a triangle. That is 100-degree angle. Solve for that. I'm scared of that. So have you like mastered writing backwards?
Yes, I've tried to.
It's easy, do it.
I'm gonna get this outside angle. I'm gonna get the outside angle. Who's done this with us?
I don't think I should.
Oh! Hey, come on, sit up front here. Come here. Over here. Get over here. We're gonna make you learn.
I just didn't feel like something.
It's not even like a.
Wouldn't it be 8 plus 30?
Which is?
Oh.
110. 57 would be.
What?
That's what we told me.
You trust him? Anyway, so back to this stuff. When you have slopes, there are 4 types of slopes you can get. Do you remember what they are? What direction can they go? What's one of them? You're thinking of equations. I'm thinking of slopes. The values of slopes, there's 4 different types of values of slopes. Well, they're all diagonal, aren't they?
So, yeah, so kind of think about that. It's diagonal, maybe going in a certain direction.
So they go from, they go like,
That wouldn't be a slope. That'd be a parabola, wouldn't it?
hold on, Mr. Let me look back at it.
Like, they go on the graph.
Yeah. What directions they?
There's one way they go right and up, and the other way go left and up.
So you go right and up like this, and you're saying left and up?
Yeah.
Okay.
All right, you're on the right track.
You go left and down.
Is it right and up, left and down?
No, it's right.
No, can't you go side to side? Can't you go side to side?
Left and right, okay. What was that?
And then you can go,
Side to side.
And then what was the other one? I heard you say it. Which one's this?
Positive. Positive.
Positive. It's positive. So you have 4 types of slopes, ladies and gentlemen. You have what's called a positive slope. And like you said, it's up and right, so this is positive. Up and right is the exact same thing as saying down and left. They're the same direction. Right? Up and right is the same direction as down and left. Depends on how you. Oh yeah, I remember that.
I never understood that.
This sloping,
Slope
so
man.
if you're down here and you're going up, it's a positive slope. If you're going down, it's a negative slope. If it's a vertical line, it's undefined. There's the U. If it's a horizontal line, it's a 0 slope. It's slope line.
What about the straight line?
Huh?
What about the straight line?
Aren't they all straight?
Straight up and down? Straight up and down, is that what you're talking about?
yeah.
Right here, it says, it's the nose, it's undefined. See the U? It's undefined slope.
Undefined?
Yeah.
So when you look at values that create things that are undefined, last year in algebra, one of the things that you guys did is that you guys solved equations. You did some work with what are called polynomials. Does that vaguely ring a bell?
Yeah.
So one of the things that you guys did is that you guys had something like this, and you had it set up to equal whatever. And when you look at this, what can't x be? Which is it? What can't x be here? Can't be 2. Because if it's 2, what becomes of the denominator? It becomes 0. Can you divide by 0? No. That's where the undefined slope comes in. Okay? Your undefined slope, if you look at your equation, if this value in the denominator, if the x values are the same, you have an undefined slope. That means the x values remain constant. So the x value goes up and down, and then that never changed, which means it's undefined, because 7 minus 7 is 0. 3 minus 3 is 0. 17 minus 17 is 0. So if you get a 0 in the denominator, it becomes an undefined slope. So what we normally do is, like we were saying with slope band and all, when we talk about the idea of our slopes, a positive slope, that would be your slope is a positive number divided by a positive number. Okay? That would be then up and right. When we graph things, when we walk our slopes, your first step is always to go up or down. So I would say this would be up and right. Okay? Yeah, and that's where this gets into, and we'll get into that also. And also, if you have a positive slope, isn't a negative number divided by a negative number also positive? And that goes in line with the same idea. Or if I say negative divided by negative, that would be down and left. So if you go up and right, sorry, it's easier if I show you something. Let's look at this graph real quick. I don't normally use graph paper. What's that, bud? Not for this stuff. I don't worry about it. We're not doing systems at all here. But if I'm talking about a positive slope, I'm starting here and I go up 2 over 1, up 2 over 1, up 2 over 1. It's the same exact thing as if I say I go down 2, left 1, down 2, left 1. Because down is negative, going to the left in a graph is also negative. Then that's when this comes into play. Okay? So up and right is the same thing as down and left.
It'd be like, goes from that way.
And then negative slopes would be the other way around. Okay? And that's where this comes into play. That's how this stuff works. So your negative slope usually one of the things that happens when you have fractions that are negative, like for example, negative 2/3, when we write the negative symbol, we generally put the negative in the numerator. Textbooks, worksheets, things like that, a lot of times what they will write it as negative 2 over 3, and they put that fraction bar in front of, they put the negative symbol in front of the fraction bar. That means the fraction is negative. You can float that negative symbol up or down, and it works either way. I'm pretty sure you guys might have seen that at some point in time. It's just when we, yeah, as long as you're constant with it, it's fine. So the idea here is if this was a slope of negative 2/3, my first step would be to go down to right 3, down to right 3. That way, my first step is always up or down. My next step is always to go to the right. Down and right is the exact same thing as going up and left. Okay. Just so you guys remember, down and right is the same thing as up and left. So I'm up and left out of here. I am not funny. I get it.
I read something and it was about this undefined slope that, I don't know, it used to be called infinite. Did it used to be called infinite?
Not that I ever remember. I think, are you thinking of systems where it's the same line and that's infinite solutions?
Oh, maybe that's what I'm thinking of.
Because that's,
I thought I was reading about like undefined slope, like why it's called undefined and how it used to be called, it was like infinite, because it was like infinity.
well, this still goes on, right?
Yeah, yeah.
So, the best guess is, you guys all did, last year when you graphed stuff. Did you guys graph? No, you that knowledge when you were to graph those. Let me show you something. Yeah, and this kind of goes with what you're thinking of. A minute ago, I showed you guys. I think it was 3 over x minus 2. I think is what I wrote. If you actually looked at a graph of that, what you're seeing is what's called it's like the greatest picture. Then that following weekend, Pearl Jam came out, and they played the video of his walk-off with Ricketts on stage with the trophy, and they played Bodie's walk-up music, Rebel Rebel. It's awesome. I'm not a shush. Yeah, she was thinking infinite Manly versus vertical. So what was the equation I just said? It was 3. This should show up. So what happens here, and I think this is where you're thinking, you get this asymptote. Asymptote. What's that? Yeah. An asymptote is the idea of a value that you approach, but you don't quite get there. Because you can't divide by 0. And again, remember how I said at 2, you can't divide by 0.
Right.
So as you get infinitely closer and closer to 2, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you. You start to scowl at it. You get infinitely closer and closer to this value, but you will never touch it.
Okay.
Okay, so
Even though it's going on forever and ever, it's never going to get to
because in math, there's always a number closer than the next number.
It's the same stuff with different items.
That's what, I think that's where you were getting at.
Okay.
Does that make sense?
Yeah, that does.
So that's what you call it. That's an asymptote.
Okay.
Anyway, back to this. So we have negative slopes go down and right or up and left, means the same thing. Positive slopes up and right or down and left. So. And then you have your horizontal lines. When your slope is 0, this is a horizontal line. Horizontal line. What's the second letter of the word horizontal?
Oh, wait, line. I thought you meant the second letter.
I did say the second letter of the word horizontal.
I did get it right.
No, you said it wrong.
How? You said
What's the
four.
second
That's
letter?
not like, oh. After you said it, then you went, oh. Anyway, what's the second letter of the word horizontal? Oh. What's the slope of a horizontal line? Oh.
Oh.
Now, if you have a graph, again, back to the idea of what graphs look like. Horizontal lines, bring this in front here. Horizontal lines move left to right, correct? What doesn't change on a horizontal line? You're looking at the graph. The direction, okay? Direction between left and right. So it's, but what value, your x or your y value doesn't change? The y value. The y value, remember this is your y-axis, the y value remains constant for all horizontal lines. Okay? So to have a slope that's 0, when you think about the formula for slope, if the y value remains constant, you get 0 in your numerator. Because if the y value is the same at every one of these ordered pairs, if my y value is at 3 here and it's 3 here, what's 3 minus 3? 0. Does it matter what the x value is? No. So when you have a horizontal slope, your equation winds up being 0 divided by some number. Horizontal lines are always have an equation of y equals some number. That is some. You're thinking back to systems of equations. We're not doing anything with systems right now, so you don't have to worry about the system stuff. Okay? We're not worried about that. What I'm looking at here is whenever you have a horizontal line, what remains constant? The y value.
Zero slope.
0 slope. Thank you. Yep, we're good.
Zero slope.
But if you put it up against there, wouldn't that be an x value? No.
This? Well, this would be a bad example of showing a vertical slope. It's still vertical, but it can be level. So when you have a 0 slope, that just means that your y value was the same. And then, again, one of the things you'll find out if you're putting this stuff in your calculator, if we're doing ordered pairs like we will eventually, if you just type it into the calculator, this will come out as 0. Okay. Or if you notice the values being the same, that just means from the y value, it means you have a 0 slope. Okay. Now the difference between that and a vertical line, well, horizontal go left and right, verticals then go up and down. So when you look at your, what we call our undefined slope, we look at the graph again. That just means that your, there it is. That just means that this value moving up and down remains the same. If it's not changing left and right, and it's just that same value of x always, that's why the x value remains constant. So for an undefined slope, it's when you try to find your slope and you get 0 in your denominator. You get some number in the numerator, it doesn't matter what it is, because the y values can change. But you have 0 in the denominator. If you have 0 in the denominator, you can't divide by that. That's why it's what we call undefined. Your calculator would just say error. Okay?
Yeah.
So the vertical line, that means this is a vertical line, and every single vertical line has the same start of an equation. It's always, always, always x equals some number. In this case, the x value that it is -3. That line has an equation that x equals -3. And that's kind of what we're starting with today. Slopes. Slopes, slopes, and slopes. Move, move. Do that. We're getting there. We're getting there. Okay? So, for an example, let's find the slope between those 2 points. We have what are called ordered pairs. Ordered pairs are just coordinates on the graph. We're not worried about graphing these things. We're just going to use the formula itself to try and solve for the slope. Suggestion that I would make, especially the first times that you do these things, if you struggled at all, just label them. All I'm doing is just putting, giving them some specific value. Is it the first x, first y, second x, second y? And then for the first few days, or the first couple times you do this, take 2 seconds and write the formula out so that you don't forget it. Because this is not something that we give you. This is something you have to do. Right. So as you write that out, then you would just substitute in the values that you have. Y sub 2. Do you guys know why we say Y sub 2, not Y2? Y1? You ever heard of a thing called a subscript? The subscript is when the value of this number is written kind of below the line. A superscript is when it's written above. So, for example, like x squared. That's a superscript for the 2. The subscript is just below. So we would say y sub 2. The reason we don't say y2 is because it implies y times 2. It's just one of those mathing terms. So you just start substituting, and then 2 minus a -6 over 7 minus 4. Yeah. It's 8.
You're lying.
I'm not lying.
Oh, yeah, because it's a negative. I forgot about that.
So here's the thing, guys. This is where having the having a calculator that has the fraction bar becomes super, 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 super handy. Because when we deal with slopes, we do not use decimals and we do not use mixed numbers. Basically, your mixed numbers will no longer exist here. So it was 2 minus -6 over 7 minus 4. And these calculators will do all that work for you. It'll simplify any fraction that you get, and you don't have to worry about trying to do any of that. Okay? You cannot walk decimal slopes, nor can you walk mixed numbered slopes either. Okay? So mixed numbers, no more. There will be a time, second semester of your Algebra 2 class, that you will use a mixed number again, but up until then, you won't use them at all. Okay? And the only reason we use that is because it's easier to count. May? May. Okay. Let's try another one. So what do you get for a slope of this one? So what? 4 minus 3, negative 11 minus 8. So we have so 4 minus 3, negative 11 minus negative 8. So this is 1 over negative 3. So you'd say your slope is negative 1/3. What's that? When you have fractions, just like you were saying, when you're talking about slopes and stuff, if the numerator is negative or the denominator is negative, it doesn't matter. Because if you think about how that meant, if it was, if my slope was 1 over negative 3, that means I'd go up 1, left 3, up 1, left 3. Isn't that the same thing as saying down 1, right 3? It means the same thing. It does not. All 3 fractions, when you have them written out, a lot of times you see negative 1/3 is the exact same thing as negative fraction of 1/3, which is the same thing as 1 over negative 3. All 3 of those mean the same. It's just more commonplace to float the negative up. That's just how normally we do. Plus, if you put it in the calculator will do that automatically.
You do a positive. No, it's a negative. Don't hurt your brain on this. Just press the button in the calculator. Right.
All right. So there's your slopes. The other thing that have come into here then is how do you write equations that deal with slopes? And this goes back to what you were just saying a minute ago about slope-intercept and what we call point-slope form. Now, when we use these things, one of the most common one that we use is this form called slope-intercept form. Slope-intercept form is super easy to work with. The reason why we use it all the time is because y equals. As we get to upper level math, calculators have a button on there that says y equals, which allows you to graph things in a calculator. What we also know is that the value of m obviously is your slope. This value of b is what we call the y-intercept. The y-intercept is where? On which part? The up and down axis or left and right axis? The up and down one, okay? So this is just a very quick way of graphing. For example, and I'll come back to point slope here in a second. I haven't given you guys any graph paper or anything like that, but if we wanted to graph the equation y equals, we'll use that negative 1/3 x plus 2. What's your slope? Negative 1/3. Your slope is negative 1/3. What's your y-intercept? 2. So when you graph something like this, you always start at your y-intercept, and then you walk your slope. The slope says negative 1/3, so my first step is to go down 1, and then to the right, 3. Down 1, right 3. Down and right is the exact same thing as going up and left. And then we would just connect the dots. We'll get to that here in a second. I have some examples for us with graphs and stuff here in a minute that we'll do on our own. But that's where slope-intercept forms. That's why we like that, because it makes graphing really, really easy. The other form that we use quite a bit of is this thing called point-slope form. This thing called point-slope form is kind of the working model to get to slope-intercept. Point-slope is for when you have a point, some ordered pair, and your slope given. Because the formula allows you to substitute in those things. You get this idea of y minus the y sub 1 is your slope times the x minus the x sub 1. Now, last year in Algebra 1, you used this a ton. This basically takes, it's what we call a parent function, which is just a generic equation, and then shifting it left and right, up and down. When you had point-slope form, for example, if we have a slope of 2 and an ordered pair of negative 3 and 4, careful. When you have your equation, the point-slope form would look like this. Y minus the y sub 1 is your slope, x minus your x sub 1. Well, here's your slope, here's your x sub 1 and your y sub 1.
This is only x1 and y1 and only put in 4 and y1.
Yes. The negative 3 goes in the x sub 1.
And then 2 will go ahead.
Yep.
You're right.
Yep, and that's basically it. If you'll notice, if you look at this setup here, guys, you've got 1, 2, 3, 4, 5 different variables. You know 3 of them. The other 2 fall back into this. So as you have done this before, you would just directly substitute y minus 4 is 2 x. Instead of writing minus and negative, what did we always write? Plus 3, very good. Good. You have to remember to distribute that here and here. You get 2x plus 6. Very good. This would be your, that's how you're able to convert from one to the other. Point-slope form is a very, very handy method. We will be using that a ton. It is a very workable setup for us, so we like to use that one a lot. Right? Excuse me. I probably don't want to get too far into writing the equation stuff. I just wanted to make sure we solve those things. Now, what I want to do real quick is remind ourselves on how do we get the slope? How do we plot things and stuff like that? So what I did is I made these things real quick so we have some better pictures. What I want to do here real quick is I want to walk you through I want you guys to scroll down. Look down to number 7. Number 7 says sketch the graph. wants to sketch the graph of the following: y equals -1/4 x plus 3. This goes back to the idea of where does that negative float? Where should we think that it goes to? The top. Always think of it as the numerator is the negative value. So when you're looking at it, just know that my first step after I start to plot these things would be go down 1, right 3. My slope is -1/4. Where is your y-intercept here? It's at 3. So when you go to sketch graphs of lines, the easiest thing to do is to always start at your y-intercept. And then what I like to have you guys do is to always fill up your graph with as many dots that fit. What I mean by that is I'm going to walk my slope however many times I need to. I know I have to go down 1, right 4, down 1, right 4, down 1, right 4. And I know that if I go any further, I'm off my graph. So I would just stop. And then I would go the other direction. Up 1, left 4. Up 1, left 4. Yeah. I just want you guys, I want you guys to try and fill up the entire line with however many fit, just to get the habit of filling in the graph, because now you have an idea of where everything's going. Okay. And you just connect them through. Do you have to put lines on the arrows on the outer edges? It's not the end of the world. Does it have to be absolutely perfectly straight every time? No, it's going to be a little crooked here or there. It's not a big deal. I don't mind. But what I do want to look at is look at number 9 real quick. Number 9. That's not in either of our forms, is it? But could we get y by itself?
Yeah.
What would you do? Add y. Good. We could add y to the other side. And then what would I do with that 3? Very good. I'd subtract it coming back. So I would wind up with 3x minus 3 is y. Does that y have to be on the right-hand side? Can I rewrite it as y equals 3x minus 3? That's fine. It doesn't change anything. And then you could graph itself. Okay. Same basic idea. All right. It would be the same basic idea. Do the first term. All right. Okay. All I want, because we're running short here, let's just get through the first 10 for today. Okay. You've got, basically it works out to being, you've got what, 6 slopes to find, and you have 2 more graphs to do. So really it's only 8 problems you got. Now, when you're given the 2 points on the graph to actually find your slope, do you guys know how the easiest way to do that is? Let's see, it's at... Do you guys know the easiest way to do that? This is number 1. You know the easiest way to figure that out for your slope? Count. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots. So I went down 6, and I go over. Ready? Let's count. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6. Thank you. And what's -6 divided by 6? 1. Just count. And you have to sing the song in your head, otherwise you're going to fail.